Good afternoon. I welcome you once again to our class, and today we want to study on databases. We want to learn what databases are. We want to understand the world of databases, and so I'll be giving you a quick introduction to databases, and we'll get onto the PC and start learning about databases. Alright, someone will ask, what is a database? Now, the answer I will give is that a database or databases are behind all of IT. The information technology we know, it is powered by databases. We use a lot of data in IT. We use a lot of data every day, and IT is all about information. So this information, where are they stored? We talk about information technology. This information, where do we store them? We have some systems we call databases. Maybe you have never heard of a database, or you have never created a database or used a database, but what IT experts do to make IT successful is that we create and we manage databases. Databases are behind all our mobile devices. Databases are behind all our operating systems. Databases are behind all our web applications and websites we know. There are databases behind all of technology. If you have used Facebook before, Facebook can never be possible without a database. Without a database, we will never have Facebook. So maybe you don't know what databases are, but databases power Facebook. Have you used YouTube before? I think you are even watching this video on YouTube. Now, this video, after recording, will be kept in a database before you can see it. It is a database that holds the data that runs the world. So databases are behind everything. Mobile apps, websites, software, all our machines are powered by databases. And so, as someone who wants to know something about IT, you want to learn about IT, you want to be an IT literate, you want to use technology, you have to be introduced to databases, and that is what we want to do. In this course, we'll be taking database lessons step by step, and the first database platform we'll be learning is from Microsoft. It's called Microsoft Access. Microsoft has several database systems. We have Access, we have Microsoft SQL Server, we have other database systems from Microsoft, but the very first one we'll be talking about is Microsoft Access. Access is the easiest database program in the world to learn. Anyone can learn Access. Access is so simple. If you want to learn Access, there are only 4 objects you have to study. The first one is called tables. Second, we have queries. Third, we have forms. And fourth, we have reports. We are going to teach you how to create tables, forms, queries, reports. We are going to help you understand what they are, how they look like, and how to apply them, how to use them. So I want you to stick around with us in this course, and we will have our first lesson today. After that, we'll have several other lessons. So I want you to subscribe to this channel, and you'll be getting the updates, and you follow through with us till you too become an expert in databases.
Databases are all around you. Have you ever waited at the doctor's office while the receptionist punched in your information? Or asked a store employee to check their system for a special item? Then you've seen a database in action. The truth is, they're so useful you see them all the time. With Microsoft Access, you can manage your own database to suit the needs of your business or maybe the company you work for.
But what exactly is a database?
Well, it's a collection of information or data that's stored on a computer, allowing you to enter, access, and analyze it in a way you never could on paper. Let's think about that. Before computers, what sort of paper records do you think the doctor's office kept on file? Certainly a list of patients and their contact information, also their medical history and a list of past appointments. That's how databases work, from the simplest to the most complex. They're basically a collection of lists, Not on paper, but on your computer, where programs like Access make it possible to organize your data, make it searchable, and so much more. Let's take a look. Say you're a hardworking amateur baker. You might decide to keep a database of all the cookies you know how to make and the people you make them for, your friends and family. A simple database because it only contains 2 lists. If you were a professional baker, your database would contain more. You'd have products and customers, and other things to keep track of like prices, sales units, and a list of orders.
Does Access actually keep these things in a big, long list?
Not quite. Instead, it uses tables, like the ones in Excel, to list things in a little more detail. Take this example from the Amateur Baker's database. It lists friends and family, but also important information like who has a nut allergy and the rest of the table. So, if a database is essentially a collection of lists stored in tables, and you can build tables in Excel, why Access? Why do you need a database at all? Let's compare. While Excel is great at storing and organizing numbers, Access is better at analyzing and connecting other types of data. For example, names and descriptions, or your friends and their favorite cookies. The databases you'll be working with in Access can actually understand how different lists and their contents relate to one another. We call this a relational database for its ability to understand relationships, and it's really what sets Access apart. Let's think about what that means while we go back to our Amateur Baker's database and build a third list to keep track of batches of cookies and who they're for. It's easy to see the relationship here. All I did was pull Dwayne from this list and Shortbread from here. Access can see and use that relationship too, but Excel can't. All of these things are completely unrelated as far as Excel is concerned. That means you wouldn't be able to pull from one list to another. Eventually, you'd find yourself typing the same thing over and over every time you needed to refer to Dwayne or your shortbread recipe or Dad and chocolate chip. In short, Access thinks more like you. It recognizes that the items in these 3 lists are connected. That makes entering, searching, and analyzing data so much easier, whether you have 2 lists or 20. Less to type, less to keep track of. Even the most complicated tasks can be made simple and user-friendly once you understand how Access and databases work.
All right, good afternoon. How are you all doing? I'm so happy to see all of you once again. We want to continue our studies, and today I'm starting a new topic on database management. And database is a major part of IT that all of us need to understand very well. If you have never heard of it, then you are not really aware of the IT world. If you don't know some of the database systems, then you lack a lot of knowledge. And if you have never used a database system yourself before, then you have a lot to learn. So this is what I want to introduce to you. And I want you to understand that databases are the backbone of information technology. Databases are the backbone of information technology. In IT, we deal with data. Without data, we will not have IT. IT is all about information technology. And before technology, there is information. And this information, it needs to be stored. And this information needs to be processed somewhere for us to be able to make sense of it. So all of IT is about handling information and handling data. And the systems we use to store our data and access our data are called databases. So that is what we want to look at. And after we look at the introduction, we will delve into one of the major database platforms for basic office database management, and it is the most easiest database system to learn, and that program is called Microsoft Access. So we'll be getting into Microsoft Access, a fantastic program from Microsoft that teaches you how to use databases and helps you use databases in an easy way. Access is very easy to understand and easy to learn. So we want to get into Access, but before that, let me do some quick introduction to databases, and I'll look at the definition. What is database management? Database management refers to the process of using computer programs to store, modify, and extract information from a database. This is the definition of database management. The computer programs used are generally referred to as DBMS. The computer programs used in database management are generally referred to as DBMS. In the world of databases, we use a lot of acronyms. So DBMS is what you'll be hearing in the real world, but DBMS stands for Database Management System or Systems. A database management system stores data in such a way that it becomes easier to retrieve, manipulate, and update. We are talking about databases. Let me tell you, IT can never run without databases. Databases are the backbone of IT. Without databases, we will never have mobile apps. We will never have softwares. We will never have any website. We will never have Facebook. We will not have YouTube. This channel that you are watching this video on, we will not have it without databases. How does YouTube store all the videos people upload? And how does YouTube recognize who uploaded which video and which channel which video belongs to? Let me tell you, YouTube uses database systems to store all the videos people upload. Now they are using a more complex big data database management system, and probably they are using NoSQL database management systems. But without databases, we will not have YouTube. When you visit YouTube, YouTube stores your computer address. YouTube knows your location, knows your country, knows the time you visited. YouTube will check all of the history they have about you and know the kind of things you like on YouTube. And any video you watch, YouTube will store it in their database, and the next time you pick any other device that you want to visit YouTube, as soon as you log in, YouTube will show you only videos you like or videos you have watched in the past. YouTube picks a lot of information about you that you have no idea of. YouTube will also compare your data with the data of people who like the things you like. So let's say you like some type of music, someone else also likes the same type of music. YouTube will suggest some of the things the other person likes and suggest them to you because you may also like them, because someone who likes what you likes something else that you have not seen before. And that is the algorithm YouTube is using to suggest meaningful information to you. And so most of the time you get a lot of suggestions from YouTube as to the kind of videos you should watch. Without the data they are collecting, it will be hard for them to maximize or keep people on their site. But they've done an intelligent job, and when people go on YouTube, they don't even want to leave. Someone can be watching YouTube and fall asleep, and the YouTube will now be watching the person, because YouTube is doing an amazing job with databases. Without databases, we will not have Facebook, we will not have Twitter, we will not have LinkedIn, we will not have Pinterest, we will not have StumbleUpon, we will not have Tumblr, we will not have Snapchat, we will not have Vimeo, we will not have all the social media platforms you like, including Telegram and WhatsApp and Snapchat and what have you. Databases are the backbone of information technology. So you have to get an introduction to it. If you love IT, you need to have some lesson on databases. It is so important. And I'm so happy that we get to see it. All right. So over here, database, it says that a database, this is a definition of databases. A database is an organized collection of data held in a computer so that it can easily be accessed, managed, and updated. What is a database? What is a database? This time, I'm not talking about database management. I'm not talking about database management systems. These are different things. I'm talking about database itself. What is a database? A database is an organized collection of data. Okay. A database is a collection of data. Let's break it into pieces. A collection of data, but collected in an organized way and stored in a computer. A database is a collection of data which is organized and stored in a computer. Why do we have to organize it? So that it can be easily accessed. Because what is the use of storing data that you cannot access? A database is like the warehouse of data. When we store data, we are not just dumping the data. We store the data to use. So a time will come for you to access your data, manage your data, and update your data. Databases are made up of a collection of tables of data. Databases are made up of a collection of tables of data. What that simply means is that inside databases, we only have tables. Inside databases, we only have tables. In databases, the data themselves are organized in the form of lists, just like the video said. In databases, the information or the data are organized in the form of lists, and they are groups of lists, and each group is stored in a table. And a table is what we know as having columns and rows. That is how databases work. If this room was a database, when you enter this room, you see several tables. Each table is a list of data. Each table is a list. Any table you find is just a list of data. The database is where the data is stored. That is why it says that databases are made up of tables, of a collection of tables of data. Tables in a database have columns and rows, like I said, but technically in the world of databases, we don't call them columns and rows. We know columns, we know rows, but in the world of databases, they are referred to as fields and records. Please, can you see this? Fields and records. So today you are hearing database terms. In databases, when they talk about fields, you know what they are talking about. Fields refers to what? Columns. These are IT terms. Records refers to what? Rows. So we have fields and we have records. Excellent. Now you can see that database itself can be shortened as DB. DB. So DB is database. Now let's look at the database table. Now, have you seen this table here? This is how databases look like. If you ever open to databases, if you ever open to a database, you are going to see several tables like this. These tables hold the data. And you can see that the data is in the form of a list, having headers and cells, and each cell contains something. But we said the columns are called what? Fields, and the rows are called what? Records. If you ever want to know anything about databases, this is what you have to understand first. Inside databases, we only have tables. A database cannot exist without a table, because it is a table that stores the data. It is not the database itself that will hold the list. A database needs a table, because it is a table that stores the data. Excellent. Let's continue. So what is a database table? A database table is a named data set in a database that is organized by columns, which are called fields, and rows called records. Fields form the table structure, and rows form the data content. All databases are made up of tables. Every database has at least one or more tables. A database cannot exist without a table. The data stored in a database is actually held in the table within the database. Technically speaking, the tables hold the data and the database holds the tables. Did you hear that? Did you hear that? Technically speaking, the tables hold the data and the database holds the what? The tables. Let's pay attention. Each table stores a particular type of data. Each table stores a particular type of data. So in a database, you are going to find several tables. Any database you will see anywhere, for a school, for any hospital, for a university, any organization, they have several tables, and each table holds one type of data. I'll get into that later. Each table holds one type of data. For example, a company's database may have a table that stores employees' personal details, another table that stores monthly salary payments, and a third table that stores sales records. So each table stores a particular type of data, and that is very important. Are you with me? All right, let's look at database fields. I've already talked about fields. A field is a technical term for a column in a database table. A field holds a single column or piece of data in a large table, such as the first name, surname, postcode, date of birth, etc. The fields determine the structure of the table. So this particular table, it has several fields. This table has several words. Each table has several fields. Now, if you pick one field, you'll realize that all the data found in that field belong to one set of information. For example, over here we see first name. Everything we'll find under this field is a first name. Does that make sense to you? Over here we have indicated one complete field, and this field has a title what? Surname. And everything you find here is a surname. That is why we said that a field holds a single piece of data. But this single piece is a single piece of every item within the table. It's a single piece of every item. So when we pick one field, we pick something from every one or every item in the table. Let's move down to records. Database record. A record is a technical term for a row in a database table. A database record stores a complete set of data of a single item in the table. such as all the data about one particular person, a sale, or product. All the records in a table form the entire content of the table. So these are all records. These are all records. And a record is an entire row. It's an entire row. And what this part is saying is that a record stores a complete set of a complete set of data of a single item. So when you pick one record, you pick every information about one item. If the items in the database are people's information, when you pick one record, you pick information, every type of information about that person. So every record holds a complete set of information. It is not like fields that holds just one piece of everyone's, something about everyone. But a record is an entire set of every information about one item or one person in the database. So this database is holding information about people. So when you pick this record, the record 3, everything you see here is for this person. I don't know how someone's name will be Road and Runner. Don't worry about that. But everything here is about Roadrunner. Roadrunner was born on 19th of October 1948. So everything you find on this record, this called record, on this record is about that person. All right, so this is very, very important. Let's continue. All right. Now, what we see here is called relational database, or RDB, relational database. And in modern database management, you cannot study about databases without hearing relational databases. It is not possible to study about databases without hearing relational databases, because modern databases are all relational databases. Please, are you with me? Modern databases are all relational databases. That simply means that all the tables within the database have relationships. All the tables within the database have relationships, and they can talk to each other. I will explain that very soon. Excel is not a relational system. Excel cannot exchange data in a way, cannot exchange data with other sheets in a way that a database can. I will explain that. So a relational database is a database structured to recognize relations between the stored data in the various tables of the same database, and sometimes in other databases. In other words, a relational database is a database that allows related data to be stored across multiple tables and linked by establishing a relationship between the tables. This provides an efficient way to store data, as you can enter data once and then reference it from elsewhere in the database. For example, a typical business database that stores customers' orders would include a table for customers having certain fields like customer ID, name, and on in the same database, and it can store orders which may have fields for product name, customer ID, and so forth in a different table. A user of that database could obtain personal details of customers that place the orders due to the relationship between the customers table and the orders table, and that is very simple. Let me explain. Do you see this diagram here? This is a diagram of databases. Anytime a database diagram is showed, this is how it will look like. These are the tables, and when we say these are the tables, it means that these are the fields within the tables. I'm going to explain this for you to get it. Let me explain what this is saying first, then I'll talk about this. All right. I want to find a certain picture here. Let me use this picture to explain what that passage said. Okay. Now, do you see this man here? He's designing a database. This man is a database administrator. Anyone who designs a database is called a database administrator, and his job is to plan and design databases and then implement the plan by creating the database and using the database with a database management system, DBMS. Now, how do you start a database? You start a database by planning it, and this is exactly how we plan databases. Over here, you will see the names of the tables. These are tables he intends to create. So he will write the name of the table. These are the tables. So we have products, we have cats. I want to read the tables, and you will tell me which system he's building. Now, this is what I mean by that. When you are building a database for a university, the kind of tables you create can tell someone that this is a university's database. When you are building a database for a supermarket, your table names and the fields you use will tell. When you are building a database for a mobile app, it will tell. Now let's look at the table names and the fields. The name of this table is called products. This one is called cart. This is called orders. These are other items, inventory, customers, login, category. And for each table, these are the fields within the table. When we are planning databases, we don't plan databases with the records because we don't know the records. The records are the information that will come in when we are done. So we plan the database with the field names. Once you know the name of your table, you have to indicate which fields you will be using to collect data. So if this is a table I am creating, once I give this table a name, such as employees personal details or employees table, I need to know that I'll collect a field, I'll use a field called employee ID, last name, first name, gender, title, and so on. These are the fields that will come in the employees table. So this is how it works. You write down the name of the table, and then you write down the fields you will use. Please, does this make sense to someone? Yes. Good. Then there's another table here called carts, and these are the fields. Others, these are the fields. Let me look at the table here called customers. These are the fields. That means in the customers table, he's going to collect this information. Let's look at them well. He's going to collect what? Customer ID, first name, last name, address, city, state, zip, country, people, email. He has a table for login. He has a table for orders. He has a table for inventory and category. Who can tell me the system he's trying to build? Who can tell me? By looking at the table names. Pardon? Okay, so he's designing a database for an online store. When you look at this login table, it tells you that this is an online store, an e-commerce website where people will have to log in and shop. Where people will have to log in and what? And shop. So that's the table he's designing. If he doesn't design this table, nobody can place an order on the website. All the orders will come into this table, and all the products that will show on the website are coming from this database. Without this database, nothing will work online. Okay, now the relationship we're talking about is this. We have a table here that is not storing anything about others, but it is storing only customer information. Do you think it is necessary to collect information about your customers? Yes. So this table here only stores information about customers. If you want to know anything about your customer, come to the customers table and you'll find their address, their telephone number, their email, and you can contact them. This table doesn't store anything about others or shopping or anything. It just stores all your customers' information, their personal details. Is it necessary? It is necessary. But there's another table here that is storing all the orders. This table stores every order, and one customer can place 5 orders and can place an order today, next week can place another order. This table stores only information about orders. But in relational databases or modern databases, we do not store personal information in an orders table. Any database administrator who designs his database to store personal details in an orders table knows nothing about databases. So how can we have orders and not know the customers? We will know the customers, but we don't collect any customer information into the orders table. That is wrong. How can we know which customer placed which order? We know it because we are going to create a relationship between the orders table and the customers table. And every order will be linked to a customer because it is a customer who will be placing the orders. So watch this. Inside the orders table, do you see an arrow coming down to the customers table? Okay, now this arrow coming from the orders to customers, what is it pointing at over here? Customer ID. Now check in the orders table whether you see customer ID somewhere. Do you see customer ID somewhere? Good. So in the orders table, we will pick an identifier which has already been created in the customers table, and that customers table will store special identity codes of each customer, and that ID will be in the orders table. And because we have the ID in the orders table, any order can be tracked back to the customers, and any information about whoever placed the order can be found. Let's say we have the orders table and we have several orders, and we want to get a telephone number of the customer who placed the order. We are not going to see telephone number in the orders table, but we can get it. The reason why we can get it is because this orders table is related to the customers, and through the ID here we can trace it to pick the telephone of the customer who placed the order. And so in database design, we design special tables for each category of information, and we create links. We call them relationships. We create relationships between the tables. So this table here, what you are seeing here are the relationships. What you are seeing here are the relationships. And when the relationships are created, any information you want to find, they will all work together as one to give you any information you want because they are connected. And because they are connected, we don't repeat data. Imagine customer addresses were stored in orders table, and you know that one customer can place several orders. What if a customer changes where they stay or their address? Do you have to go and check every order and correct the address in every order? That is going to be a tedious work. And if an address is changed in one order and it doesn't correspond to the address from the other orders, the information will not look, the information will be different. And so if something like that happens, the address information is just changed in the customers table, and because they are linked, the address, we can find the address of the customer no matter the order we look at. Because of the relationship, we don't have to repeat data at several places. The data is organized. This is what we mean by organizing the data, and this makes the database system work perfectly. Alright, so that's what relational databases are about. When you are designing a database, you have to design it in a way that the tables will link or have relationships with the other tables. In Access, we will see where the relationships are created. But apart from creating the relationships, when you are designing the tables, you have to know that this table, I will have to relate it to this table. So I'll find an ID and create the same ID here so that they will be used for the relationship. So you plan the relationship when you are designing or when you are creating the table in the first place. Let's say, for example, you are all students in this institute, and you are all in a database. All of you are in a database. And we've stored your personal details in our database. Now, anytime you, let's say, write an examination and your exam records are being stored, your exam records will not be stored with your personal information. Your exam records will be stored alone separately, but your student ID will be added to the table that stores your exam records, so that through the student ID we will know everything about who the records are for. Let me give you another scenario. When a database is being designed, let's say for students, several tables need to be created. The first table is called students table, and that students table is designed for personal details. So we have every personal information about you separate. Then we create tables for different types of data. For example, fees, or attendance, or exam performance. When, let's say, attendance records are being stored, we don't need to collect your home address, your telephone number. We don't need to collect or repeat. Imagine you have a table like this. This is a personal table, or a table that stores personal information. If this table were to be an attendance table, we will not need to collect all this information again. Because, do you know something? You come to school every day in the week, and every day we have to collect all this information again. Imagine how large the database will become in 3 months. The database will become a huge database, and the information in that database will not be useful that much. they are repeated data. In database design, we don't repeat data. So in your attendance database, we will only store, or in your attendance table, we will only store your daily attendance. The only additional information we will take is your student ID. With that student ID, we can connect it to the students table and know all your personal details. But that information will not be stored in the attendance table. If not, the attendance table will be too large and it will hold junk data. Because you come to school every day we have to keep storing all this information, and the table will be large for nothing. Meanwhile, we have that information already. And in case we have to update something about you, do we have to go to your attendance record and update it for each time you came to school? That is wrong. So all we need to do is to create a relationship between your personal details and your attendance. Okay, so the arrangement of the tables here do not matter, just that every table should talk to another table, and they talk to each other with the IDs that are repeated. I will explain them when we move on. So you'll be hearing things like primary key and foreign key. This ID here is called a primary key, and the ID here in the second table, the login table here, is called a foreign key. Database is the backbone of technology. It is not complex at all. Just take your time and understand it. It's just new to you. That is why you may see it complicated. It is not. All right. So when you are learning about databases, just pick the important terms one by one, and your knowledge will grow in a step-by-step manner. So now you know what a DBMS is, database management system is. We'll talk more about the various database management systems. But you know what database management is, you know what a DBMS is, you know what a database is, you know what a table is, what a field is, what a record is, and what a relational database is. A relational database is a database that recognizes relationships or allows the creation of relationship among the tables within the database. So any database that supports relationships is called a relational database. There are some databases in the past that did not support relationships, and so information had to be repeated over and over. Please, are you with me? Okay, I'm just trying to find the right words to use to give you understanding. Before computer systems came, how did business owners store their data? They used papers and books, right? So in the book, they need to write down everything. So they will have a book that stores all their customers, one book. Another book that will store all their orders day by day. Now, these two books, they cannot talk to each other. Because we now have computers, the two books can communicate. But in the past, these two books couldn't talk to each other. And so, when someone places an order, they would have to either write the details of the person in the order's book, or they could also use an ID to relate to whoever placed the order in the other book. Okay. For now, Don't be worried about how complex anything looks. Just pick the simple terms. You've heard of DB, database management system, table, field, record. Just keep that in mind. Keeping that in mind is the first step. I don't expect you to be experts in databases in 1 hour. Just keep these things in mind. Remember that there's something called a field and a record. If you can even remember that there's field and record, you've captured something. Alright, now let's look at DBMS. DBMS stands for Database Management System. And it says that a database management system is a computer software. A database management system is what? So it is a software application used for creating and managing databases. So there are computer programs that are used for creating databases and managing databases. Any program like that is called a DBMS. So which program do you know that can create and manage a database? I know of Access. I'm sure you've heard of Access. So Access is a DBMS. Which other program do you know that can create and manage a database? Oh, I've heard of a program called SQL Server. Maybe you have not heard of SQL Server. It's a program. Please, are you with me? Yes. So SQL Server is a DBMS. It's a database management system. There are other ones that you may not have heard of, but these are all computer programs. Please, have you heard of Excel? Excel is a computer program. If you've heard of Excel, then you know what a computer program is. It is the same as saying, have you heard of SQL Server? SQL Server is a program. At advanced level, it is a server and a program, but it's just a program that is used to create and manage a database. And we have others that we'll be looking at, like MySQL, PostgreSQL, and Oracle, and others. Okay, now a database management system, DBMS, is a computer software application used for creating and managing databases. A DBMS makes it possible for end users to create, read, update, and delete data in a database. We call that CRUD. We call that what? CRUD. CRUD means create, read, update, and what? Delete. So a DBMS makes it possible for end users to CRUD data in a database. CRUD means to create data, read, update, and delete data in a database. The DBMS interacts with end users, applications, and the database itself to capture and analyze data. All we are talking about is the backbone of IT. At the backbone of IT, we deal with data. This data needs to be stored in an intelligent way. So the way we can keep our data for IT to move on and advance is through systems like this. Now let's look at RDBMS. In the world of database, we talk a lot about, we use a lot of acronyms. Did we talk about DBA? Or we've not gotten there? Oh, I have skipped DBA. Can you imagine? Okay, I'll come back to DBA. Okay, let me talk about DBA now. DBA stands for what? Now, DB stands for what? DBMS stands for what? RDBMS stands for what? Okay, so when you hear DBA, DBA is a job role. It's called database administrator. You can be employed as a DBA. And as a DBA, we'll see what you do. The term DBA stands for Database Administrator. A database administrator directs or performs all activities related to managing a database. Database administrators use specialized software to store and organize data. The role may include capacity planning, installation, configuration, database design, migration, performance monitoring, security troubleshooting, as well as backup and data recovery. Simply put, a database administrator plans a database before it is created, and he goes ahead to create the database in a database management system, and his job is to monitor how the database is used, and if an error occurs, he fixes the error. His job is to watch the database and handle the database to make sure the database is running, because when the database breaks down, the IT systems cannot work in the company anymore. Have you ever been to a hospital that when you went there, you just mention an ID, or you just give them a small card and they entered into a computer and they got every information about you? Yes, they are using a database. If the database is down, they can't get any information about your medical history to know what is wrong with you. A doctor will not ask you too many questions. A doctor will check your medical history. How will he check your medical history? He will go into the database and get every information about you. Then he will know what is wrong with you better. Nevertheless, he will listen to you, but he knows what to do through your medical history. Are you with me? Let me quickly talk about RDBMS, and I think I will bring the first part of the lesson to a close. I think we are almost done. We'll talk about access next time. So let me just come here and talk about RDBMS. And RDBMS is what you have already heard. It simply means Relational DBMS. You know what a DBMS is? RDBMS is a relational database management system, which is a type of DBMS that uses a relational model for its databases. In other words, not every DBMS uses a relational model. In the past, databases couldn't create relationships, but modern databases can establish relationships. So they are using a relational model. So DBMSs that can create relationships are called relational database management systems. And almost all the modern database management systems are relational. Almost all the modern DBMS that we have around are relational. All the ones you can think of today are relational. In advanced systems, we talk about NoSQL or NoSQL database systems, and that operates in a different way, but at this level, almost all the database systems you hear about are relational. So an RDBMS therefore enables you to create relational databases. Simple. The difference between RDBMS and DBMS is that RDBMS enables you to do what? Create what? Simple. It helps you to create relationships amongst your tables. That's all. Relational database management systems have become the most popular type of DBMS. Most major DBMS are relational. Okay, what are some of the major DBMS around? Now, over here you don't see the logo of Access, but this lesson is going to talk about Access. So Access is one. Number two, what is here? So we have Access, SQL Server, and you do know that SQL Server is also from Microsoft. So when you come here, it is called Microsoft what? Okay, so we know that Access is from Microsoft, right? We call it Microsoft Access. After Access, if you want to move to an advanced system, the next advanced system from Microsoft is SQL Server, Microsoft SQL Server. Then do you see this here? This is the one of the most advanced database systems in Microsoft right now. Microsoft SQL Azure. If you want to call it Azure or Azure, it is one of the most advanced database systems in Microsoft right now. Now, the next one you see here on this list is what? SQLite. SQLite is a database behind mobile apps. Have you used a mobile app before? Have you used a mobile app before? The database that makes your mobile app work is SQLite. So SQLite is used for mobile apps. SQLite. SQLite. All right. Then over here we have more SQL Azure from Microsoft. And we have the almighty Oracle database. Oracle is a high-level database system used by highly secured IT systems and organizations. So when you think of the banks, most of the banks are running their databases on Oracle. In banking, all their security depends on their database. Their database is where their vulnerabilities are, and if a hacker gets access to their database, their entire system will just collapse. After this lesson, if you can remember 5 database management systems, then you have really gotten a good start in understanding databases. Now, I was talking about the security of banks. A bank, if a bank database falls, the entire bank will collapse in one day. All their vulnerabilities are in their database. If a hacker gets access to their database, it can collapse the bank. What do I mean? All the account balances of their customers are simply entries in their database tables. If someone hacks into a bank's database and let's say the person has $2,000 left in his account, his foreign account, and the person has 4 zeros to 8 in that table, he has collapsed the bank. It is as simple as adding 4 zeros to what is in the account. So $2,000, if you add 4 zeros, you get what? $20 million. The person can walk into the bank and confidently withdraw $20 million because that is what is in their database. The reason why your bank knows the balance you have and you are able to collect an amount is because of the balance in their database. The bank doesn't remember you every day and they don't remember what you came to put in. Anytime you come for withdrawal, they will check your balance. And the balance is just the record in their database table. Whatever is there is what they will give you. If what you are requesting is less than what is there, they will cash it for you. If it's more than what is there, they will tell you your check is bounced. Have you ever had a bounce check? Okay, it means the balance was not enough. So imagine a hacker getting access to a bank's database and adding 4 zeros to every customer's balance. You add 4 zeros to every customer's balance. Or turning every customer's balance to 0. There will be war in the bank. So, all the security that any bank needs, or the first level of security, is to ensure that their database is safe. Because if the wrong people get access to the database, they have big trouble. So you can see how important a database is. Okay, so we're talking about Oracle, and we are saying that this is a highly secured database system, and most of the banks are running Oracle. Then we have MySQL. MySQL is the database behind Facebook and websites and web applications. So when you go online, the database you are dealing with is usually MySQL. Then we have FileMaker, we have Postgres SQL, and several others. I want you to remember 5. Let me pick 5 for you. The first database system that you should learn is this. This is the most basic and simple and easiest database platform in the whole wide world. Microsoft Access. Maybe you have not gotten into Access before, but if you work in database field, or if you work in IT and your work relates to database, you know that Access is the most simple database out there. So if you want to learn about databases, learn Access first. After Access, you migrate or you progress to another system. Alright, so I want you to remember Microsoft Access. So whenever you are asked to mention any DBMS, even though they are RDBMS, they are also DBMS. RDBMS simply means they are relational DBMS. So they are still DBMS. So Access is the first to remember. Number 2, you have to remember this, SQL Server. You cannot forget this. You have to remember SQLite. This is behind all your mobile apps. You have to remember Oracle. You have to remember MySQL. These are the 5 I'll pick for you for now. The first time I mentioned Oracle to my students, they told me that it's a Nigerian movie. Because they didn't know, and I asked them what is Oracle. And their minds went onto Nigerian movie, spiritual things in Nigerian movies. But please, in IT, when you say Oracle, you are talking about a powerful system in databases. Alright, so I picked 5 for you. I said you should remember this. These are common ones you'll be meeting. That's why I'm mentioning them for you. Microsoft Access, SQL Server, SQLite, Oracle Database, MySQL. When I finish, I'm going to go around and everyone is going to tell me these 5. Alright, the last thing I'll say before I bring the first part of my Access and Database Management lecture to a close is Database Engine. Database Engine. What is a database engine? All you have to know about database engine is that every database has an engine. And because we are going to learn about Access, we will learn about the engine behind Access. Alright, so a database engine or storage engine is the underlying software component that a database management system uses to CRUD data from a database. CRUD means to create, read, update, and delete. So it is the underlying software component that a DBMS uses to CRUD data from a database. Now, the database engine of Microsoft Access is the Microsoft Jet database engine, simply known as Microsoft Jet. So when you are asked, what is the database engine behind Microsoft Access? The database engine is called Microsoft Jet. Or, if you want to mention the whole thing, Microsoft Jet database engine. That is the engine behind Access. The engine behind what? Access. Alright, so keep in mind that every DBMS has an engine, and the engine behind the DBMS we are learning is called what? Microsoft Jet database engine. So this is the part 1 of our database lecture. This is the introduction, and some of the terms you are supposed to hear, we have mentioned them, and later we'll be talking about other important terms like primary keys and foreign keys and queries and other important terms. All right. Now, for your assignment, go and research on these terms, because without them we don't have databases. So I have some of them here, the important database terms. Query, number 1. Primary key, number 2. Foreign key, number 3. Data type is number 4. Schema, form, report, and SQL. SQL is huge. SQL is huge. That is why it repeats so much in databases. You can never learn database without hearing SQL. Some people call it SQL. It is SQL. This SQL, it is a language of databases, and later we'll talk more about SQL. And when you advance, you can learn how to code in SQL. Alright, so these terms, I want you to go and read about them. Next time, I will pick them one by one and talk about them. Alright, so let me end my lesson here. And next time, we will continue. So thank you for joining me on this channel. If you have not subscribed to this channel, make sure you subscribe so that you'll be the first to be notified anytime a new video is uploaded. On this channel, you'll learn things like IT, networking, graphic design. You'll learn coding. You'll learn mathematics and several other parts of technology. So thank you. I will see you in the next video. Bye.